Hello, ladies and gentlemen. This is Ms. Skokan. We are here to work on section 8-5, which is the last section in chapter 8 that we're going to be working on. The section is titled The Law of Sines and the Law of Cosines. And right away, I want to tell you that this is what we use when we can't use right angle procedures such as SOHCAHTOA and Pythagorean theorem. So our first objective, or our only objective, is to use the law of sines and the law of cosines to solve triangles. Just a reminder that solving triangles means that we're finding all the angle measurements and all the side lengths. We've got two quick warm-up questions for you to work on, so turn the video back on when you're ready to move on to the lesson. If you had any questions about any of these, and this was mostly calculator work, but if you have any questions, definitely bring your questions to class. Example 1 we are not going to be working on, and so let's move forward. Newsflash, not every triangle is a right triangle. When we don't have a right triangle, we need to use things that still work for other triangles. Two of those things are law of sines and law of cosines. The law of sines says for any triangle ABC with side lengths A, B, and C, and remember the way that we name triangles is the name of the vertex is opposite the name of the side that has the same name but with a lowercase letter. So anyhow, we have, for any one of these triangles with side lengths A, B, and C, you can see we have this proportion, which sine of angle A over side length A is equal to sine of angle B over side length B, which is also equal to sine of angle C over the side length C. You're only going to ever use two of these at a time, and the proportion allows us to solve for whatever is missing. Imagine that we're looking for side length A. Whenever we set up a proportion, which is ratio equals ratio, we have four different things. The numerator on the left, the denominator on the left, the numerator on the right, the denominator on the right. We need to have three things that we know and only one that we don't know. That's how we solve a proportion, and that's how we're going to solve the proportion with the law of sines. When we're solving for side length A, we're going to use our cross multiplication, and we're going to have A is equal to side length B times the sine of angle A divided by the sine of angle B. Now, I know sometimes students see the sine in the numerator and the sine in the denominator and think that somehow you can cancel them out. But remember, each time you're taking the sine of an angle, it's not the sine by itself. So it's the sine of angle A, sine of angle B. Those are two different angles. So it's going to be two different sine values of those angles. And remember, sine is just the opposite over the hypotenuse in our right triangle. Anyhow, this is how we solve for side length A. We can also use the law of sines to find a missing angle measurement. Imagine that angle B is our unknown and what we want to solve for. We start out with the same proportion and then we use our cross multiplication, solving for the sine of B. We end up with sine of angle B is equal to side length B times the sine of angle A divided by side length A. Well, we're not done yet because we don't really want the sine of angle B, we want the measure of angle B. So we need to take the inverse sine of both sides. And that brings us to the measure of angle B is equal to the inverse sine of B times the sine of angle A over the side length A. And that's how we would solve for the measure of an angle. I know that this seems like it's really fast and it's a new skill to you, but don't worry, as always, we're going to have some practice problems that are going to help us through. So let's go ahead and take a look at the example on the next page. The instructions for example 2 are use the law of sines, find each measure, round lengths to the nearest tenth, and angle measures to the nearest degree. So let's start by labeling our triangle. Side lowercase h is across from vertex or angle H. Side G is across from angle G. And side F is across from angle F. So the question is asking us to find the length between points F and G, or the length of segment FG, and that side is also called side H. Now let's figure out what we have and what we want. Remembering that to use law of sines, we need to have 3 out of the 4 items in our proportion, and we need to have 2 of them that are across from one another or opposite one another. We want to find side H, and that means we're going to use angle H. Our proportion is definitely going to include sine of angle H over side length H. The other side length and angle combination that we have is side F and angle F, which measures 39 degrees, and that's what's going to be on the other side of our proportion. So our proportion is set up, and we know that we are solving for side length H. As always, when we're solving a proportion, we use our cross multiplication. Our strong pre-algebra and algebra skills tell us that side length H is going to be equal to side F times the sine of angle H divided by the sine of angle F. Now all we need to do is plug in. Side F is 40 long, sine of angle H, which is 32 degrees, divided by the sine of angle F, which is 39 degrees. Now we've just got some calculator work to find H is equal to 33.7. This was an example about how to use the law of sines to find a missing side length measurement. In part B, we're going to use the law of sines to find a missing angle measurement. We're going to start by labeling our triangle with the side names. So we've got triangle PQR, so we know the angle and the side that are opposite one another have the same name, lowercase and uppercase. And this time we're trying to find the measure of angle Q. The only way that we can use the law of sines to find angle Q is if we definitely have side length Q and another pair of angle and side that are opposite one another. In this case we do. So let's start setting up our proportion. Sine of angle Q over side length Q is equal to the other pair that we have, which is sine of angle P over side length P. As always, we're going to use our cross multiplication to solve the proportion. And our algebra skills tell us that the sine of angle Q is going to be equal to Q times the sine of angle P over side length P. Now let's plug everything in. And we recognize that this will give us the sine of angle Q, but we also remember we don't want the sine of angle Q, we actually want the measure of angle Q. And that means we're going to need to use the inverse sine on both sides. So we're going to take the inverse sine of the left and the inverse sine of the right. On the left-hand side of our equation, that's going to leave the measure of angle Q, and on the right-hand side of the equation, we're going to take the inverse sine of 6 times the sine of 51 degrees over 8, and the rest is calculator work. When we put this in our calculator, we get the measure of angle Q as 35.7 degrees. We were asked to round to the nearest degree, so that gives us 36 degrees. Just a reminder that it's super important for us to show our thinking. We're not in the business of proving that we know how to do calculations, but we are in the business of making sure we can show our thinking and the logic behind our steps. On the next page, you've got a Now You Try to practice these new skills using the law of sines to find a missing side length and a missing angle measurement. There are 2 problems for you to practice on this Now You Try. The first one is finding a missing side length measurement, and the second one is finding a missing angle measurement. Remember to turn the video back on when you're ready to check your answers. Hopefully you were able to apply the law of sines to both of these questions. As always, if you have a question about something, make sure to bring it to class so that we can go over any questions that you have. With Theorem 8-5-2 and Example 3, we have another tool that we can use to find missing side lengths or missing angles. This one is called the law of cosines. We have the law of cosines because the law of sines cannot solve every triangle. When we have only side lengths or 2 side lengths with the included angle, the law of sines is not going to work for us, so that's when we use the law of cosines. Theorem 8-5-2, the law of cosines says for any triangle ABC with side lengths A, B, and C, and then you see these different formulas that we have that are solved for the side length squared. Now, we know that if we're finding a side length, what we can do is take the square root of both sides and find the missing side length. If we're looking for an angle measurement, then we're going to need to rearrange algebraically, solving for the cosine of the angle, and then use the inverse cosine in order to find the angle measurement. Let's see what it looks like with example 3. We'll start by labeling our sides and recognizing that what we're trying to find is side length y. Next, let's write down what the law of cosines says. Side length A is equal to, the square of side length A is equal to side length B squared plus side length C squared minus 2 times the length of side B times the length of side C times the cosine of angle A. I want to draw your attention to A and A being almost like bookends on the two sides of the law of cosines. This is going to be how we write it each time. Now, in this example, example A, we don't have A, B, and C. We have X, Y, and Z. So let's set it up using our X, Y, and Z. Since we're trying to find Y, we're going to set it up as Y squared is equal to, and now the other two sides, X squared plus Z squared minus 2 times the same two side lengths that are on this side, X and Y, times cosine of the same side length that's on the left-hand side of the equation, angle Y. Now let's take the square root of both sides. And that's going to leave us with Y on the left-hand side, and on the right-hand side we're going to have the square root of 30 squared plus 35 squared minus 2 times 30 times 35 times the cosine of 110 degrees. The rest is calculator work. So when we put this all in our calculator, we end up with Y is equal to 53.3. Remember that what we just found was a side length, and we were asked to round lengths to the nearest tenth, which we have done. This is what it looks like to use the law of cosines to find a missing side length. Now let's take a look and see what it looks like when we're trying to find a missing angle with question B. We want to find the measure of angle T, this angle right here. Because we want to find the measure of angle T, that means that T needs to appear on both ends, the outside ends of our law of cosines equation. So let's set it up that way. T squared is equal to R squared plus S squared minus 2RS times the cosine of angle T. Now I just realized that I forgot to write down the side length names, so I'm writing those down now so that we can use them in our equation. Solving for the cosine of angle T is going to be a little bit more algebraically intensive, so I'm actually going to plug in now, and then we'll rearrange with actual numbers in the equation. So T squared is 7 squared equals R squared, 11 squared, plus S squared, 13 squared, minus 2 times 11 times 13 times the cosine of angle T, which is the one that we are missing, so that stays as a variable. So we end up with 49 is equal to 121 plus 169 minus 286 times the cosine of angle T. Now I know that this is going to look weird, but I'm going to add 286 times the cosine of angle T to both sides. And what that's going to leave on the left-hand side is 286 times the cosine of T plus 49, which is going to be equal to whatever's left over on the right-hand side, which is 121 plus 169. Then, of course, we are going to subtract 49 from both sides. And that's going to almost isolate cosine of angle T. It's going to be 286 cosine of T is equal to 121 plus 169 minus 49. That's going to give us 286 times the cosine of angle T is equal to 241. Now, of course, we just divide both sides by 286. leaving the cosine of t on the left-hand side, and on the right-hand side, I'm going to leave it as 241 divided by 286. The last step is for us to take the inverse cosine of both sides, which on the left-hand side is going to leave us with the measure of angle t, and on the right-hand side, to the nearest degree, is going to give us 33 degrees. We have found our missing angle measurement. Remember that when we're trying to solve a triangle, we need to find all the side lengths and all the missing angles. So I know this is a little challenging when first presented with it, so it's a great opportunity to have it now. You try to practice the law using the law of cosines. The law of cosines is given to you up above, solved for a, b, and c squared, a squared, b squared, c squared. So you can practice. On question A, you're going to be finding the missing side length, BC, which we know is lowercase a, and on the right-hand side, you're going to be finding the missing angle measurement, the measure of angle R. Remember to turn the video back on when you're ready to check your work, and just be patient because it's new and it might be a little bit awkward at first, but you will definitely be fine with this. See you back in a few minutes. So we've got one example remaining in this section and then we're done, and it is a real-world application of using the law of sines and the law of cosines, and that's on the next page. The Leaning Tower of Pisa is 56 meters tall. The tower makes a 100-degree angle with the ground. To stabilize the tower, an engineer considered attaching a cable from the top of the tower to a point that is 40 meters from the base. How long would the cable need to be? What angle would it make with the ground? Round the length to the nearest tenth and the angle measured to the nearest degree. We're always tempted to see if we can use the law of sines first. So let's see if we can use the law of sines. We would need to have 3 out of the 4 things in our proportion. So if we're trying to find angle A, that means we have to have side length A, which we have, and we would need to have another pair of side and angle opposite one another, which we don't have. So that means we need to use the law of cosines. And we can use the law of cosines to either find the measure of angle A or side length B. Since the law of cosines is a little bit easier to use when we set it up to find a side length of the triangle, let's use the law of cosines to find the length of the cable, which is labeled B in our triangle ABC. The law of cosine says b squared is equal to a squared plus c squared minus 2ac times the cosine of angle B. We know we're going to take the square root of both sides to find B. Let's plug in the values and then let our calculator do some of the work for us. Once we've got everything plugged in and into our calculator, we find that the length of the cable is 74.3 meters when rounded to the nearest tenth. Now we've got the measure of angle B and the length of side B. So we're all set up to use the law of sines to find the measure of angle A. To set up our proportion, we're going to use the sine of A over A because we're trying to find the measure of angle A, and that's going to be equal to, and we're going to use the pair that we have, sine of angle B over side length B. Let's plug in our values now. Sine of A is going to stay sine of A because that's what we're looking for. Side length A is 56 meters long. That's going to be equal to sine of 100 degrees, which is the measure of angle B, over side length B, which is 74.3 meters. And now we solve for the sine of angle A. Once again, we rely on our pre-algebra and algebra rearranging skills, algebraic manipulation, and we end up with sine of angle A is equal to 56 times the sine of 100 degrees divided by 74.3. Last step, we need to take the inverse sine of both sides. That's going to leave us with the measure of angle A on the left-hand side, and the inverse sine of 56 times the sine of 100 divided by 74.3 on the right-hand side, which brings us to the measure of angle A is to the nearest degree equal to 48 degrees. To practice this skill, once again, you've got to now you try. So you're going to work on this and turn the video back on when you're ready to check your answer. I know you can do it. These do take some practice to get comfortable with, but they're definitely not hard, and especially if you start by labeling your triangle and writing down the formula, it actually is pretty plug and chug oriented. All right, we're done with our lesson for today, and it's time to move on to homework, and I'll see you back in class.